All right, characteristics of polynomial functions. First, we've got a typo in this one as well, that the plus 0 at the end should be plus a sub 0, so that's right here where I rewrote it in green. This is just giving us a list of our vocabulary words for this section, and they're very important vocabulary words for you to understand so that when I use them in class or you see them on an assignment, you know what it's talking about. So degree is the highest power of the variable in the polynomial. So whatever the highest exponent is, we call that the degree of the polynomial. The leading term of the polynomial is the entire first term with the coefficient, the variable, and that highest exponent. The leading coefficient is the coefficient of the leading term. And the constant term, see there's where that typo was up here, but it's correct here, is the term with no variable. If all we have in our polynomial function is just a constant term, it's a linear, flat equation, right? And the degree of that polynomial function would be 0, because it basically would be the variable has an exponent of 0, so we don't even bother to write it. The graph of a polynomial function is smooth and continuous with no holes, vertical asymptotes, jumps, or corners. So there is nothing that we can plug into a polynomial function that will make it be undefined. There's no fractions that would cause us to divide by 0. There's no roots that would cause us to take the square root of a negative number. There's no logarithms that would be restricted, or exponentials where the variable is an exponent that would change the exponent for the value of x. So those are important little details to abide by when we know it's a polynomial function. Okay, here's our examples. We're going to find the degree, the leading term, the leading coefficient, and the constant term of each of the following functions. So I'm assuming these are all polynomial functions. So let's start by focusing in our leading term and then our constant term. So our leading term tells us the degree is 5. The leading term, I'm just going to call it LT, is 4x to the 5th. The leading coefficient, I'm going to call it LC just because I don't want to write that all down, is just the 4 at the beginning of our leading term. And our constant term, so constant term, is -5. Okay? The cool thing about the constant term that maybe I should have said on this page right here, you might want to write this in, the constant term is also the Y-intercept. And the reason that constant term is the Y-intercept is because the Y-intercept happens when x equals 0. So if you plug in 0 for all of the x's, the only number that doesn't cancel out because of multiplying by 0 is that last constant term. So the constant term is always the Y-intercept. So that's why it's kind of important for us to know what it is, because it's also the Y-intercept of our graph. We're not graphing these right now, we are just identifying the details. Now be careful, sometimes our polynomial functions are not written in general form, which is with the highest exponent first. So pay attention to that. So that means that this is our leading term. So our degree is 3. And why is that the leading term even though it's not written first? It's because it has the highest exponent. The leading term always has the highest exponent. So degree 3, our leading coefficient is 1. If there's nothing there, it's an invisible 1. And then for this particular one, our constant term, or I'm just going to start calling it the Y-intercept because that's really why we care about it. Our constant term doesn't exist. There is no term that has no variable on it. So that means the Y-intercept is 0. Just because it's not there doesn't mean it doesn't have a Y-intercept. Polynomial functions always have a Y-intercept. It's just if it's not written, it's 0. Okay, this one looks a little sketchy because of the fraction. But don't be afraid, just rewrite it. So just to keep this in general form, I'm going to rewrite it here. I'm just going to change too far and did too much. Okay, I'm going to rewrite how this function looks a little bit. I'm going to put my leading term first. That's not quite how I wanted to rewrite it. Put my leading term first and my constant term last. So take a second to look at what the equation did look like and how I changed it. Does it mean the same thing in the way that I've rewritten it? The answer to that is yes. Definitely means the same thing. So now we have our degree is the highest exponent. Well, there's no number on that exponent. When there's no number there, that's our invisible 1. So we have degree 1. Our leading term is negative 1/5 x, or just negative x over 5. Our leading coefficient is negative 1/5. And our y-intercept, or constant term, I didn't mean to put an equals on it, y-intercept is 4/5. Alright, this one's a little crazy. Are we going to have to multiply this whole thing out to know the answers? The answer to that is no, thank goodness. We don't have to multiply the whole thing out. We just need to look at all of the leading terms and their exponents so that we can figure out what's going to happen. So I just circled all of those. I'm kind of covering up. Whew, didn't mean for that to move. I'm going to lock this in place. Okay. I'm just going to thin out those lines a little bit so that I can see better what I circled. So what I want to do is, this is just a polynomial function that's in what we call like factored form instead of general form. So general form is what we have to have these in order to get these correct answers. So in general form means it has to be multiplied out. I don't know if I spelled that right. It looks a little weird, but I think it's just my handwriting on this tablet. Okay, so this is in factor form. So in order for us to figure out the first and the last term, because that's all we need is the first term and the constant term. We don't need to know the terms in the middle for the instructions for this particular problem. So all we need to do our leading term is to multiply this stuff together. So we have 2x to the third. Let's ignore the negative 1 for now. We're going to have times an x for this second factor, and then times a 3x for the third factor. So let's multiply all of that together. So 2 cubed, 2 times 2 is 8, times 3 is 24, and then we have x times x times x times x times x. X to the 5th. So instead of having to FOIL everything out, where I multiply this together times itself 3 times, and then multiply that in, and then multiply that in, whew, we could do all that if we needed to do more than what these instructions are asking us for. But since the instructions are just saying to find the leading term and the constant term, for the leading term, all we need to do is multiply our leading terms together with the correct exponents. So there's our leading term. That tells us that the degree of this polynomial is 5, because that's a 5, in case you can't read it. Our leading term is what I wrote right there, 24x to the 5th. And then our constant, no, I'm not to the constant term yet. I'm just doing the leading coefficient. Leading coefficient, that's an L. C, is just 24, and then we need to figure out the constant term now. So for the constant term, we're going to take this to that power times this, okay? So negative 1 to the third times negative 2 times positive 2. So it's really kind of like we're multiplying all the factors together, but we're ignoring all of the middle stuff. I don't like how that 2 looks. There we go. So negative 1 to the third is still negative 1. Negative 1 times negative 2 turns into positive 2. And positive 2 times positive 2 is positive 4. It's going to suddenly... my computer start working again, and I'm going to have like a million 4s written right there. Anyway, so that will be our y-intercept. Maybe it's not going to write it for me.